I'm going to solve these 4 word problems, and for each it's helpful to use a chart to arrange your thinking in order to set up the equation or the proportion that you use to solve the problem. Okay, let's go ahead and get started. For the first one, we have 2 different painters working on a house, and we're thinking about how much time it will take if they work together. Okay, so as we've done with these charts before, the very first thing we're concerned with is the categories. So we'll put those here. And what do we have? We have a painter, we have an assistant, and actually the possibility of them working together. Okay, so we have painter, assistant, and together. And normally, or on the other charts, we were putting a variable in right away, but we were also trying to get numbers in here, and these types of word problems just don't set up like that. All right, so we don't have a lot of information on the paper here, so the very first thing we're going to do is just get some numbers on the paper. So this will be they talk about the total time it takes to finish the house. So total time to finish job. And for the experienced painter, it's 7 hours. For the assistant, it's 9 hours. And together, we don't know how long it will take, so we'll use our variable. And if you think about it, I guess this is consistent. We were saying variable. Usually we try to get a variable in this first box, and it appears that I've done so. But the point I want to make here is when they work together, it better be less than 7 hours, right? If the person can do it by 7, and it's a woman. Okay, so if she can do it in 7, if she gets help, she better be able to do the job in less than 7 hours. All right. So, but the trick that you use for actually solving this, and it's a pretty cool trick, is we're going to look at the time or how much of the job they can do in 1 hour. So, part of job done in 1 hour. And think about this for a second, just to see why the heck does this work. Okay, let's say the painter could do the whole job in 2 hours. In 1 hour, how much of the house would be painted? 1/2 of the house. All right. Let's say the painter could do the job in 4 hours altogether. Take 4 hours. In 1 hour, the painter would have painted 1/4 of the house. So kind of convince yourself that this works. It's a cool trick. We have a painter taking 7 hours. So in 1 hour, she can paint 1/7 of the house. The assistant can paint 1/9 of the house in 1 hour. Sorry, that 9 doesn't look so good. Let's see if we can bring that up a little. looks more like a 9. And when they work together, we don't know, but it's the same pattern, 1 over x. Okay? And if we take this much of the house painted and add it to this much of the house painted in 1 hour, it's going to equal this much of the house painted in 1 hour. So where to put these guys? I think I'll just try to go to the side here. So if I have 1/7 of the job plus 1/9 of the job completed in 1 hour, that's going to be a total of 1 over something of the job completed in 1 hour. Okay, and the way we've been clearing our equations of fractions is just multiply by the product of everything. So 7 times 9 times x, 7 times 9 times x, and 7 times 9 times x. And now we just cancel what we can and stay with what we've got. 7's cancel, so 9x times 1. Bring down your plus sign. The 9's cancel, 7x times 1. Bring down your equal sign. The x's cancel, 7 times 9. If these were big numbers, I might not multiply them, but 63 is not too hard to work with. We can combine these two terms, so that'll give us 16x equals 63, and divide by x. Divide by 16, not x. I want to keep x. I want to get rid of the 16. So divide by 16, divide by 16. And now my 16's not looking that good. Oh, that's much better. Alright, so these cancel and you get x equals, looks like I'm moving off my screen. This really isn't going to clean up nicely. I'd be content to leave it like that, but we're talking about time. It looks pretty strange. So we'll make a mixed number. 4 times 16 is 64. So it's 3 15/16. So that's what our x is equal to, and we can actually say that they can do the whole job in just under 4 hours if they work together. Okay, we'll take a look at the next one. We have a pump draining a pool. Move in a little bit. So again, we'll start out with our categories. And it's a similar approach. So let's see, we have first pump, second pump, and also when a second pump is used, it only takes 6 minutes. How long would it take the second pump drain pool? Okay, so sometimes they use them together. I'll just use the word together. All right, but we end up with 3 categories here. And this will be total time, and we will have a variable in here. Total time to drain. Alright, so the one pump, we'll call that our first one, can drain the pool in 12 minutes. Alright, so 12 minutes. The second pump, okay, when the second pump is also used, so that's together. So they're using the first pump and the second pump. They can drain the whole pool in 6 minutes. And then how long would it take the second pump to drain the pool if it were the only one? So that's our X. We don't know. And we're going to use the same trick we used on the previous one. Part of pool drained in 1 hour. Alright? Too many eyes up here. Alright, oh, not hour. 1 minute. Alright, because we're in minutes, so how much of the pool can they drain in 1 minute? It's just hard for me to think of draining a pool in minutes. Must be a small pool or a big pump. Okay. It's the same trick. In 1 minute, they can drain 1/12 of the pool. The second pump drains 1/x, and together they drain 1/6 of the pool. If I add these two, I get this. So we'll work that off to the side. So 1/12 plus 1/x is equal to the part the first pump does plus the second pump is equal to what they accomplished together. And we'll clear it of fractions the way we've been doing. Multiply each term by the product of all the denominators. If I write 12 times x times 6, that starts looking like a multiplication sign. So I'm going to put 12 times 6 times x, 12 times 6 times x, and 12 times 6 times x. Now we'll just cancel whatever we can. 12's cancel. 6x times 1. Bring down your plus. X's cancel. 12 times 6. Again, that one's not so hard. 60, 72. And the 6's cancel. 12x times 1. And let's get rid of this 6x. So we're left with 6x equals 72. We need x by itself. So we will divide by 6, and x is equal to 12. It might not be a real satisfying answer, but The second pump, if it works all by itself, is going to take 12 minutes. You have essentially two identical pumps. And in light of that, it does make sense that if they work together, it cuts the time in half. Okay, that takes care of our second one. The next one, we have a car traveling on level terrain and mountainous terrain. So we'll use our chart to set up the categories. And we've got a few more numbers on the paper here. So with our categories, we will try to get some numbers in here with number. All right, so we have level terrain and mountainous. So we'll say level, mountain, and 400 miles on level, 160 miles on mountain. So level, 400 miles, and mountain is 160 miles. Then we want our variables in this next category. Let's see what else they tell us. The rate of the car is 30 less in the mountains. So it's some speed minus 30 in the mountains, and on level ground it's just whatever that speed is. Okay, and they're helping us out. We can get this, the more organized the better, the rate of the car. So up here we have rate, and then off in here we would rewrite. And what do we have? Our distances. So this is 400 miles and 160 miles. At this point, hopefully you're realizing, okay, we have a rate, we have a distance, time is mentioned here. So you need to think of the formula. I don't want to get off screen. D is equal to RT. Distance is equal to rate times time. All right, and we have the rate. This one would be our distance. So the only thing left to worry about is time. But notice in our formula, T is not by itself. We need T by itself. So divide by R, divide by R. So T is equal to D over R, or distance over rate. So we can express time as distance over rate. So we have 400 over x, and we have 160 over x minus 30. And let's see, the same amount of time. So it tells us the times are equal. That means we have a proportion. So, where do I write this? 400 over x is equivalent to 160 over x minus 30. And let's get rid of our fractions here. So we multiply each term on each side by the product of the denominators. X times x minus 30 and x times x minus 30, and we cancel whatever we can. Here the x's cancel. You're left with 400 times x minus 30. Equals, bring down your equal sign. X minus 30's cancel, and 160x. Put a little dot there. These numbers are pretty large, and as long as I do the same thing on each side of the equation, I can do pretty much whatever I like. I'm going to divide by 10 and divide by 10. So at least the numbers are smaller. I could go again, but I'll just stick with dividing by 10s. All right. Let's move out a tiny bit. So I still need this x out of the parentheses. So we'll send it in, distribute it. That gives us 40x minus, this is going to be, I'll write 40 times 30 just to sort of show that I can do it. Equals 16x. I could multiply them together, but I'm just hoping stuff will cancel. And now we want to get rid of this 40x. So we have our negative 40 times 30 equals negative 24x. And we'll have to divide by that negative 24. So over here, of course, they cancel out, and you have a positive 1x equals. The negatives here are going to cancel, so we can stop worrying about them. And let's just see what we can cancel out. 4 goes into 24, and 4 goes into 40. So 4 goes in here 6 times. 4 goes in here 10 times. Then the 6 and the 30, you can do a little more canceling. 6 goes into 6 once. 6 goes into 30 5 times. So all that's left standing is 10 times 5. So x is 50. And let's see what the actual question was. Get this back in. Remember, we have x equals 50. Find its rate in the mountains. Okay, in the mountains, it's 50 minus 30, so it's 20 miles per hour in the mountains. And we have one more, number 12. We have a boat going upstream and downstream. So we'll start out in a familiar way, organizing our categories. We have upstream, downstream, since a lot of times if there's, the reason I like to get some numbers in here is to kind of get them out of my word problem. At this point you've got 3 numbers to look at. So categories, with number. So what numbers could I put in here immediately? It's 9 kilometers upstream, 15 kilometers downstream. So upstream, I'll put 9 km. Downstream is 15 km. And we do want our variables. And what do we say? The rate of the current is 7. Oh, in Stillwater. Okay. So going upstream, this is going to be, this isn't the rate of the, let me see, the current is a constant 7, so this will be the rate of the boat. You know, you're thinking of the speed of the boat. Alright, so if the current is 7, whatever the speed of the boat is, it's 7 miles an hour, or excuse me, 7 kilometers per hour slower going upstream. Whatever the rate of the boat is, it's 7 kilometers per hour faster going downstream. And often here we do a rewrite, so that'll be our distances. Incidentally, if you don't put numbers here, you won't call it rewrite. You'll be looking back in here for the numbers. So that's another reason. I just like to get them on the paper. And what is this? This is our distance. So this is 9 kilometers and 15. Okay, the rate, the distance, your brain should be saying, what about D equals RT? But in this last category, we want time, because that's the only thing left. So we have to divide by R, divide by R. So to express time, we just have distance over rate. So here's our distance and our rate. So for time we have 9 over x minus 7, 15 over x plus 7. And notice they said the same amount of time. So that means these two are equal. And where should I work this? So we have 9 over x minus 7, 15 over x plus 7, and we'll clear this of fractions in the usual manner. Multiply each term by x minus 7, x plus 7. And then this term gets multiplied by x minus 7, x plus 7. Cancel what we can. X minus 7's cancel. We have 9 times x plus 7. Equals, cancel what we can, x plus 7's cancel, 15 times x minus 7 to solve for x, we could make these a little smaller, but I'll just stick with what we have. We could divide by 3 and divide by 3. I'll stay with what we've got. So 9x plus 63, and then distribute this. 15x minus 105. And here, let's try to clean this up kind of quickly. I'm going to get rid of the 9x. And at the same time, see, I'm going to end up with an x over here, so I've got to add 105. And let's see what we get. 63, 105, that's 168. And here we have 6x. I guess I'll move that a little. So divide by 6, divide by 6. And you have x equals, do a little division off to the side, 168. So 6 goes in there twice. That's 8 times, so 28. Let's put that up here. X equals 28. And let's see what they're actually asking for, though. They want the rate of the boat in still water. Find the rate of the boat in still water. Oh, this makes sense. That's x. This is the rate of the boat. I could have made a third category down here that maybe would have helped that, but because it makes sense if I put well, this is the distance it travels, so you won't see it show up right there.